This video deals with conditional probability and the probability of at least one. To begin with, you're given the following Titanic mortality table and asked to answer 4 conditional probability questions. The first thing is to remember the definition for conditional probability. The probability of B given A is equal to the probability of A and B divided by the probability of A. The first conditional probability question asked us to find what is the probability that a person survived given the person is a man. So we will need to find the probability of all men who survived divided by the probability of what's given, and we're given that the probability is that the individual is a man. If you look at the table, the probability of men who survived is 332 divided by the total number of outcomes, which is 2,223. That's divided by the probability of what's given, the probability of a man, and if you sum all the men, that equals 1,692. That's divided by the total number of outcomes, which again is 2,223. When you reduce the complex fraction, you end up with 332 divided by 1,692, which in decimal form is 196 thousandths. The second question is changed just a little bit. This time you want to find what is the probability of getting a man given that the person survived. So this time, using our definition for conditional probability, we have the probability of men who survived divided by what's given, and we're given that the person survived, so we're dividing by the probability that we had a survivor. So if we look at the table, the probability of men who survived is 332 out of our total 2,223. All of that is divided by the probability of survivors, and we have a total of 706 survivors divided by the total number of outcomes, which is 2,223. That complex fraction reduces to 332 divided by 706, which is 0.470 in decimal form. The third question is also a conditional probability question. We have to find the probability of getting a man given that the selected person died. So using our definition of conditional probability, we need the probability of men that died divided by the probability of what's given, the probability that the person died. Looking at our table, if we look up the number of men who died, we had 1,360 out of our total number of outcomes, 2,223. That is divided by the probability of what's given. We're given that the person died. There were 1,517 deaths out of 2,223 outcomes. That fraction reduces to 1,360 divided by 1,517, which will reduce to 897 thousandths. The fourth conditional probability question asks us to find what is the probability of getting a boy or girl given that the randomly selected person is someone who survived. So again, using our definition of conditional probability, we need the probability of all boys and girls who survived divided by the probability of survivors. If we add up all the boys and girls who survived, that'll be 29 plus 27, which is 56. That's over our total number of outcomes, 2,223. That's all divided by the probability of selecting a survivor, which is 706 out of 2,223. That complex fraction reduces to 56 divided by 706, which is 0.0793. The last question deals with the probability of getting at least one question correctly on a quiz consisting of 6 multiple choice questions. So the probability of at least one correct equals 1 minus the probability of none correct, which equals 1 minus the probability that they're all wrong. That equals 1 minus the probability. Since there are 6 questions, we have 6 wrong answers. A wrong, and 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 a wrong answer. That equals 1 minus, the probability of answering any question incorrectly is 4 out of 5. So we have 1 minus 4 out of 5 to the 6th power. Now just use your calculator to evaluate the expression, and you should end up with a final answer of 738 thousandths.